Hello there. In this video we're going to reprove the midpoint connector theorem using coordinate geometry, but the setup's not going to be clever, so this here is going to be at some arbitrary point A, B, and these are also at arbitrary points. There's actually a much cleaner way to do this, which I think was assigned in the homework. Midpoint connector theorem has to do with connecting midpoints, so I'm going to get the midpoints at these two locations. Remember that the midpoints are found by averaging the x and y coordinates, and I wind up with that on both of the sides. So that was an application of the midpoint formula, where you take x at x, average them, y at y, average them. Okay, so first thing that is going to happen is that this line that we create, mn, we want to show that that is parallel to the bottom line, pr. And we do that in coordinate geometry by testing slopes. So that's the bottom one, and this one is going to require a little bit more setup. So I'm going to get all these things here, and you can notice, so this minus sign is going to be distributed across, and eventually we're going to have d minus d up on top, and those are going to cancel. And on the bottom, the c's are going to cancel. We'll have e minus a all over 2. And that's equivalent to f over b, or f minus b over 2, times the reciprocal of what I'm dividing by, e over a. And we get those 2's to cancel. Sure, when you're doing a bunch of these calculations that you're labeling the parts that you're finding. So what we found here was that the slope of PR was equal to the slope of MN, and that means that PR is parallel to MN. And that's half of the proof. So the other half is proving that this red length here is half the distance of that bottom length there, PR. And to prove distances, we need to use the distance formula. So I'm going to mark these as long and short. I'll do the long distance first. And I get this, so this is distance formula. You're taking the x minus the other x quantity squared plus the y minus the other y quantity squared. And that's simply how we're going to leave that one. Now the other one gets a little bit more involved because those coordinates there are more involved. Alright, so making all these substitutions, this x minus this x quantity squared, and this y minus this y quantity squared. And that eventually reduces to this. What's going to happen, so we're subtracting this whole thing, this negative sign gets distributed also to that c. So eventually we have a c over 2 minus c over 2, and those cancel out. And the same thing happens over on this side with those d's. You have that common denominator. Okay, so now comes a little bit of a trick. I'm going to distribute this 2 to the top and the bottom. But I'm a bit strategic about it, so on the top I'm not expanding it out, it's just e minus a quantity squared. On the bottom, I do expand it, 2 squared is 4. I do that over there too. Both of these are over 4, so I can factor out that 1/4. And that gets me to here. This is already looking kind of familiar. Now the square root of 1/4, that actually can be evaluated. Square root of the top is 1, square root of the bottom is 2. And we get this. And this part here, you'll notice, is exactly what we have up there, which, with a substitution, leads us to that the small is 1/2 of the long, and that was our other conclusion. Okay, so with some coordinate geometry, we were able to get there. There's actually a much easier way to do this one, and that's if you position P at, you can take this shape and shift it, rotate it, reflect it, and you can move this point here, AB, over to 0, 0, and you can slide this point down so it's actually lying perfectly flat on the x-axis, and it'll be at some coordinate generally called A, comma 0. And that makes this one flat, slope 0. This will also become flat, and the distance formula becomes quite a bit easier to do too. But if you don't do that, you can still manage to get there. It just makes the work here a bit more involved. But we're up for it. Character and Scholarship for Life.